What you really want to do with any of these is kind of get a picture of what you're looking at, because if you can't tell what is outside or inside radius, it's going to be really hard to know what you're doing for these. So if we graph this here, we have y equals the square root of x. So y equals square root of x. I'm going to do that in blue. 0, 0, 1, 1. I don't know if we need to go out this far. We got y equals 1. I think we do. Okay. Out here. All right. So we would have this graph for the square root of x. X equals 0. What line is that? Vertical y-axis. And then y equals 1 is here. I really should have made this graph a little bit smaller because we really don't need a lot of what I've got there. So if we graph those three lines, we're looking for the region between. So we've got this little area right here. I wonder if it will let me. I wonder if it'll let me make it bigger. We'll make mine bigger here, so it looks worse whenever you make it bigger. But all right, so we in this case are revolving around the horizontal line y equals 1. So when you're revolving around a horizontal line, it means everything's in terms of x, right? So even if it's not the x-axis, if it is another horizontal line, everything's in terms of x. So what we're doing is we're taking like a little piece right here, and we're revolving that around our y equals 1 line. Will this one have a hole in the middle of it? It will not. So this one in particular will not have a hole. So here is what is kind of difficult about these problems. Whenever we are doing this problem, if we use the square root of x, because when you look at this, if I ask you which line gives you the outside radius, which one is it? It's that blue line, right? So you want to say the square root of x squared here is your outside radius. But the problem is whenever you use the square root of x, that does not give you this distance right here. That gives you the distance from here to here, which is not what you're rotating around the x-axis. So if I want to find, if I know this part right here is the square root of x, but I want to find whatever this is right here, what could I do? What? Almost. You'll do 1 minus the square root of x, because we know this whole part right here is 1, and we know this piece is the square root of x, so that radius right there, this right here, is 1 minus the square root of x. And then, so on these, a lot of times we want to think about the outside radius, in this case, is 1 minus the square root of x. The inside radius, in this case, do we even have one? It touches the line everywhere that we're rotating around, so our inside radius here is 0. So you don't necessarily have to write that, but I'm just doing that because on some of these other problems, we're going to have an inside radius. So once you get your outside radius and your inside radius figured out, you're going to do these like the other problems. So you'll have pi, the integral from 0 to 1 of 1 minus the square root of x squared You could put minus 0 squared, but it's unnecessary whenever that inside radius is 0 dx. And so here, that's going to be pi, the integral from 0 to 1 of 1 minus 2 times the square root of x plus x dx. We're still squaring them separately. It's just that our outside radius and our inside radius are different here. So that this 1 minus x, the square root of x, that is our outside radius. The reason here our inside radius, that was 0. So I didn't write that, but I could have. That inside radius was 0 squared. So 1 minus the square root of x is your outside radius here. So they are still squared separately. It's just our inside was 0, so it sort of went away on this. And I'm going to show you on Gabby's in a second that she was doing here for 18, how that's really the same thing as what we were doing here. So here, and we'll do a couple more where we do have an inside radius, and you'll see the difference. So here, we're going to integrate, and when we integrate, we're going to have pi. We'll have x. Let's see. That's 2x to the 1/2, which is going to be x to the 3/2, and 2 divided by 3/2. So 2 times 2 over 3, so minus 4/3 x to the 3/2 plus 1/2 x squared, and we'll evaluate that from 0 to 1. I'll go ahead and do this one by hand because we're just plugging in 0 and 1, but you could do it with your calculator if you want. We'll have 1 minus 4/3 plus 1/2, which is going to be, let's see, 6 over 6 minus 8 over 6 plus 3 over 6. So that is going to give you, you'll get pi over 6. Okay, so I've just got the basics for you to copy down here. Your two equations, we're revolving around the line x equals 3, and we're only looking in the first quadrant. Okay, so first of all, whenever I do, all the x's and y's get me confused. Picturing things is not what I'm best at. So I'm going to need a graph. We're revolving around x equals 3. What kind of line is that? Vertical. So since we're revolving around a vertical line, everything is going to be a dy. You're doing everything with respect to y. So that's going to tell you how to do something different with these graphs right here because they're not y's right now. But let's just graph them like they are first because we know how to graph lines better whenever they're solved for y. So if we graph these, so we got 2 minus x and 2 minus 2x, and we're looking in the first quadrant. So we only need the first quadrant here. And I think we really only need to go like out to 2 here. So I'm going to graph y equals 2 minus x in blue. So it has a y-intercept at 2 and a slope of -1. So that blue line will look like this. And then I'm going to graph see, y equals 2 minus 2x in red. So it has the same y-intercept, but it's going to have a slope of -2. So down 2 over 1, it will look like this. And we're only looking in the first quadrant, so that area between the two graphs in the first quadrant, that's this area right here. Now, here is what I find a little bit tricky. If this was revolved around the y-axis, blue line's outside, red line's the inside, just do the problem, right? But we're not revolving around the y-axis. We're revolving around the line x equals 3, which is this vertical line here. So you can see right away, that's going to change your outside and your inside radius. But before we can even worry about that, let's solve these equations for x, because everything has to be in terms of y before we can do this. So here for this one, I would probably just move the x over here and the y over here. So x is going to equal 2 minus y. And then over here, I'm going to say 2x equals 2 minus y. Then you're going to have to divide by 2. So x equals 1 minus 1/2 y. I'm going to make that red. So this red line right here, this is 1 minus 1/2 y. The blue line is 2 minus y. All right, so when we're thinking outside radius and inside radius, whenever I have an equation like 1 minus 1/2 y, it gives you the distance between the y-axis and the line. All right, so this is 1 minus 1/2 y right here. But our outside radius is not 1 minus 1/2 y. We don't want that. If we were rotating around the y-axis, we would. But our outside radius is from here to the line we're rotating around. So for that green right there, what equation could I write for that value? What is the distance from here to here? Total distance. That is 3, right? So you'll see here that for that green value that I have right there, I could take 3 and subtract 1 minus 1/2 y, and that's going to give me that green distance. So we'll have 3 minus 1 minus 1/2 y, which you probably want to go ahead and simplify there. So you're going to have 3 minus 1 plus 1/2 y, so you'll get your r of x equals 2 plus 1/2 y. And so for our inside radius here, whenever you look at this part right here, that 2 minus y, that's the distance from here to the y-axis. So the equation always gives you the distance from that point to the axis, the y-axis or the x-axis, depending. So if I don't want that, if I instead want this, it's a different color. If I want this distance here instead, right, that's my inside radius. How could I get that? 3 minus 2 minus y, which if we distribute there, we're going to get 3 minus 2 is 1, and we get a plus y. In general, it should always work to take the line you're rotating around and subtract the equation to get those inside and outside radiuses. It does, you do need to draw a picture because, like, if we were rotating around the y-axis, the blue line would be our outside radius. But whenever we're rotating around x equals 3, now the red line is our outside radius. So it can change that, but you're going to have the number of the line you're rotating around minus whatever equation that you're looking at. So now that we've got our outside radius and our inside radius, we're going to set it up like we do the other problem. So we'll have pi integral, what do I integrate from? 0 to 2, and those limits come from our y-axis here, okay? Not our x-axis, but our y-axis. So 0 to 2, and then we'll have 2 plus 1/2 y squared minus 1 plus y squared, and we'll put a dy over here on the end. So on the last problem and on Gabby's problem that she had, we didn't have an inside radius because the line we were rotating around was touching that point everywhere. But in this case, our graph does not touch that line, so we're going to have an outside and an inside radius here. So now we're going to have pi integrate from 0 to 2. That's going to be 4 plus 2y plus 1/4 y squared minus 1 plus 2y plus y squared. If we combine some there, we're going to get, let's see, 3. We've got a plus 2y and a minus 2y, so those will actually cancel out. And then you'll have a 1/4 y minus y, 1/4 y squared minus y squared, so you're going to get minus 3/4 y squared dy. And for the sake of time here, let's integrate this with the calculator. So F3, integrate. We want 3 minus 0.75 x squared, comma, x, comma, 0, comma, 2, and then we get 4, and then I didn't put the pi in, so it'll be 4 pi. Okay, let's try to get this last problem in. We've got y equals x, y equals 3, x equals 0, about the line y equals 4. And so y equals 4, what type of line is y equals 4?
Horizontal.
Horizontal line there. And so I know I need to go up to at least 1, 2, 3, 4 here. And y equals x is the line, goes to the origin here, like this. Y equals 3. That's a horizontal line here at 3. And x equals 0, what's that? Vertical y-axis there. So we are looking at this area. Nice simple triangle there. But we are not rotating around that green line. We are rotating, let me make it purple. We are rotating around y equals 4. So we're going to have a hole in the middle of this graph. We're going to have an inside radius. So the outside radius in this case is the blue line. But remember, the blue line gives me this here. Joe, we're not done? Okay. The blue line gives me this here. So I don't need that part. I need this part here. So I'm going to do 4 minus x. And generally, it's always going to be that line you're rotating around minus whichever one's your outside function. For the inside radius, what's the inside radius of this one going to be? The inside radius is always the same in this case. It's 1. And if you want to think about the equations, it is 4 minus 3, because 3 is your inside equation, right, which gives you 1. Right? So whenever you set this up, you're going to have pi. We're going to integrate from 0 to 3, and those limits are coming from my x-axis, although they are the same from the y, but they're coming from my x-axis. And I'll have 4 minus x squared minus 1 squared. Okay, so let's just do this on the calculator for the sake of time. I'm sure that we can do this without it, but so we'll have pi the integral of 4 minus x squared minus 1 comma x comma 0 comma 3, and we're going to get 18 pi for that one. Okay, so your assignment is going to be from page 425. I want you to go back to 13 through 16 and do the parts that we did not do. So you've already done like the x-axis and the y-axis on those. So now do the other lines, the x equals and y equals. And I want you to do 17 through 23 odd, and then 54. It was not, but it is now. Well, that one might have been. No, I don't think. I think I added it this morning. It's 7 through 10. Well, you can do 18 now because we know how to do it, but 7 through 10 and 21 were the ones for that.